All right, good afternoon, guys. Can you hear me all? Good. Can you thumbs up? You can hear me? Cool. So thank you for coming to today's discussion. My name is Tabish. I'm one of the TAs for CS564. And today we'll be mostly going over homework 5 or assignment number 5, which is Heapfile Manager. The due date for this assignment is the 19th, which is, I think, in around 12 or 13 days. All the details of the assignment are already on Canvas, including the requirement description PDF, the code base that you'll be using, as well as the slides from today's discussion. So you can get that from Canvas. Right, so let me just present this. OK. So we'll be discussing the Heapfile Manager module of the database that you're building. We'll first talk about what the Heapfile Manager is, why you need it, and how you will implement certain parts of it for the assignment that you have. Just to refresh your memory, what we're doing in these assignments is basically building a very simplistic version of a database, right? So it'll behave somewhat like SQL, but not exactly. It will have very limited functionality, and it just implements the most core foundational parts of a database, such as the buffer manager, the Heapfile Manager, and some other parts that you'll see in the next assignments. Right. So before I start with the Heapfile Manager, I wanted to get some FAQs out of the way. So these are questions that generally students come up with, and they have doubts and confusions about these things. So these are not necessarily related to the Heapfile Manager directly, but you'll see them in the code that you will be working on. So the first thing in C that you'll see is that we have a somewhat peculiar way of returning values from C functions. So you'll see some functions like this in your code that you'll be working with. So you have a function like getStudent, right? It has an input argument, student ID. And the job of this function is just to find a student with the student ID, with the passed in student ID from some database or some list, and return that student value, right? But you'll notice something strange about this function, that is that it returns a status object instead of a student object, right? So can anyone tell me how the student object is being returned in this function? Yeah?
Wouldn't there be a pointer which in the function, the pointer is set to the address of said student, so that when you pass the pointer, when the function returns, you can still access it. Like it's kind of treated like a global variable.
Right. Yeah. So essentially what you said was correct. So we have an additional argument in this function, which is the student output. And unlike what you've seen in Python or Java, for example, where you use the inputs just to process the function and just return an output, in this case, the second argument, which is the student output, it acts as sort of a container for the return value. This is a pointer for what you will be returning, right? So you'll assign the student object, once you find it, to this student output variable, and then that will be sent to the user, essentially. So when you call this function, you'll give it a student ID, let's say 123, and you will create a new empty or a null pointer of type student and pass it in here. And then within this function, you'll find the student object, assign the student output variable, the pointer to that object, and you'll return the status, not the student, right? But from the caller's perspective, this pointer will be assigned to the correct student object. So you can use that pointer to refer to that object. Another piece of information you should have for this discussion is, you've already seen pages, right? In Buffer Manager, you had this concept that a database is divided into pages, and then you read the pages into a Buffer Manager. The way that pages are identified generally in this structure is using a page number, right? And many students just assume that page numbers are sequential like pages in a book, right? So if you have page number 1, the next page will be page number 2. But in this case, it's not so. Page numbers in this case are just sort of random identifiers. They don't have to follow a sequence. So if you're at page number 11, the next page might not be page number 12. It can be any value, greater, lesser, or whatever, right? It cannot be equal, but it can be greater or lesser, right? One more piece of nomenclature in this is a record and a row. So in this discussion, you'll frequently hear me talking about records. Now, typically, a record and a row are the same thing, right? When you insert a row into a file in a database, that will be stored as a record. But this is not always the case, right? You'll have some cases where records store something other than a row. So just keep that distinction in mind. But for the purposes of this discussion and for your project, you can assume that a record is the same as a row. The final piece of confusing nomenclature in this project is a Heapfile object on disk and a Heapfile class, right? So we'll be talking about Heapfiles in more detail, but you can just remember it like this. A Heapfile object on disk is an actual file on disk, And the heap file objects and the heap file classes, they're just programmatic representations of these files so that you can interact with these files and sort of run operations on them and perform different actions on them. So I'll distinguish them by generally saying heap file on disk, which means the actual file on disk, and then the programmatic version of it, or the way that you will sort of interact with a heap file, will be a heap file object or from a heap file class. Okay, so this is sort of the overview of the assignments that you're currently doing. You've already done buffer manager. That's the first part of your database. We're working on the heap file manager. The next part we're skipping because of, in the interest of time, and we'll finally move on to the query and update operators in the last assignment. So let's get into heap file managers. So just to quickly overview the previous assignment, which is the buffer manager. The reason for a buffer manager is pretty straightforward, right? You have a disk which can store large objects like a database, which can be of hundreds of GBs in size. Disks are good for storing DBs because DBs are large, first of all. Disks are non-volatile, so even if you restart your computers, you'll still retain data in them. But the only problem is what? Any ideas? What's the problem with just using a database or a disk for storing a database directly? Yes? Exactly, it's slow, right? It's good for for storing large objects, but it's slow to talk to a database on disk. So if you have a query running in your CPU, it'll take a long time to go to the disk and ask it what is happening and then come back. So what we can do instead is we can introduce some faster version of memory, which is RAM, this yellow box over here. The advantage of RAM is that it's much, much faster, so you can read and write data to the main memory or RAM much faster than you can to the disk. But now you have to load data from the disk to RAM, right? Which is where the buffer manager comes into the picture. So what you'll do is you'll take up your disk and you'll take the database in your disk. You can't load the whole database onto the buffer manager because it's too large. So you'll break it up into small chunks of fixed sizes, let's say 4 KB, 8 KB, whatever is convenient, right? And these act as units of transfer between the disk and your RAM. And these fragments are called pages, and each page can be inserted into a slot in the buffer pool, which is called a frame. The size of a frame is exactly the same as the size of a page. So if I'm reading some 2 arbitrary pages from the database, I'll pick them up from the disk, bring them to my main memory, and insert them in my buffer pool. Now, since the buffer pool has a limited capacity, I'll have to worry about, oh, if I have to insert a new page, do I have space in my buffer pool or not? If I don't, I'll have to evict pages out using an algorithm like first in, first out, or LRU, or like you did in your previous assignment using a clock hand algorithm. So this is a higher level sort of overview of what pages are like and how they're constructed. But let's look at some real tables and some real data, how that will be divided up into pages. So imagine you have a database with a single table in it, these 10 arbitrary rows with 3 columns. These columns have different types. And this is stored on your disk initially, and what you want is to take this from disk and insert it into your buffer manager. So first of all, what you'll do is, for your database, you'll create a file, right? Databases are stored on your computer as files, regular files on your file system. So you'll give it a file name. Then you'll decide, oh, how much do I want the page size to be, right? It can be 4 KB, 8 KB, or whatever you want. You don't want the page size to be too large, because if it's too large, then you'll be bringing too much data from the disk to your main memory, and it's just useless to bring too much information there. You can't make it too small, because if you make it too small, then you don't have enough information loaded into main memory, so you'll have to keep talking to the disk. So it has to be some appropriate size. So in this case, let's assume that we decide that each page can contain up to 4 rows or 4 records, right? So now what I'll do is I'll just divide up my database and insert them into the corresponding pages. The first 4 pages highlighted in yellow go into page 1, the next 4 in page 2, and then finally the 2 leftover rows go into page number 3. So the first 2 pages are completely filled up. Last page still has 2 slots available, but there's not enough records, so it'll stay empty until a new record comes in. So this is basically how you divide a database or a table into pages and then sort of insert them into a file. So in this structure, how do you uniquely identify a file? Like, what is the unique identifier for a file? Any ideas? Guesses, ideas, anything? How do I uniquely identify a file on my file system? A file name, right? You just give it a file name. That's how you uniquely identify it. So each file has a unique file name. Now within a file, how do I uniquely identify a page? A file can have multiple pages, right? So how do I uniquely identify a page? Yes? Yeah, page ID, or in this case, we're calling them page numbers, but the same thing, yeah. So each page will have a unique page number, not necessarily sequential as we discussed. So you can think of a page having multiple slots, right? In this case, slot 1 to 4. Each page has 4 slots, and then in each slot, you insert at most 1 row, right? So to identify each file, you have a file name. To identify each page, you have a page number. And to identify each record within the page, you have what is known as a record or a slot number, right? So if I want to go to the last page, the last record in that page, I'll go to file name, page 3, and then record 2 or slot number 2, right? All right, so that is about pages and records. Any questions so far? Yes?
Will a file typically have the maximum number of pages it can store always, or will it have like 0 pages in the beginning and then allocate pages as it needs it?
Right. So you'll be doing this in your assignment. So initially, when you create a brand new file, right, it does not have any records in it, you'll just create, excuse me, you'll just create one single page with no data in it, all right? So you'll not create more than one page than you already have, right? So you'll have one page provided that you want to insert new records there, but you will not have empty pages unnecessarily, okay? Does that answer your question? Cool. Now, in the code that you have, the way that these pages are organized or represented are somewhat like this. Pages have slots. Slots can have one or at most one record, right? And some slots can be empty. This structure is called a slotted page. And another nuance about these pages is that they're organized as a doubly linked list, right? Since page numbers are useless for ordering, they can be in any order. So we used a next pointer and a previous pointer to refer to the next page and the previous page. So if you're on a page and you want to go to the next page, you'll just use the next page pointer to go to the next page, right? And what is the unique identifier for a record? We already saw that. It's basically a page number and a slot number within a file, right? Okay. So with this background information out of the way, we can start talking about heap files. So heap files are just one way of taking a database and storing it in a file. It's just one way of organizing a database into a file. There are many other alternative ways that you can use, but the one that we're using in this case is a heap file, and it has the following few properties. First of all, the records or the rows that go into a heap file are unordered. So if you inserted a row first and then another one afterwards, there is no guarantee about which order they'll be in this heap file. They can be in any arbitrary order. They're just like normal heap files. They're just like normal files in a file system, right? You can create them, you can delete them. And if you want to interact with them, you'll open them in your program just like you open any regular file. You'll close them once you're done with them. And inside these heap files, we now know that they have pages and records, which themselves can be inserted and deleted. Records are uniquely identified by their record ID, which is page number and slot number. And we just call this pair, the page number and slot number, as RID. And there's also one more small detail about heap files, that their very first page is a special page. It's called a header page, right? It's not like a regular page. The reason it's different is because it stores some metadata about the file itself. It does not store regular records or rows in it. Okay, so why are we using heap files? Mostly because simplicity, right? It's easier to implement. There are other alternatives, but it's simple, it's easy to understand. Also because there is no ordering to these rows inside a heap file. Inserts are much faster. And I guess they're space efficient. I mean, they don't use too much metadata. They just have the bare minimum. They don't have any ordering. So I guess it's space efficient. But in modern databases, you'll mostly have some other version or other mechanism of storing files, such as sorted files or B trees or hash indexes. But we'll be storing them as heap files in our case. All right, so any questions about the heap file itself, like the heap file stored on disk? Yes.
So I read a bit about this on the write-up for the assignment. It says like that it is slightly different from the files that the files stored on the disk.
Right.
And I'm still a bit fuzzy on what the difference is between
Right.
this heap file and what we've seen in the past.
So there's already a file object or a file class in the code, but Heapfile sort of builds on top of that, and we'll see some additional constraints and fields that it adds on top of the existing file class. It adds what is known as logical ordering to those files. We'll see that in a moment once we go into the details of what fields a heap file has in addition to a regular file. Okay.
Would a heap file
No. So you can think of it like a heap file builds on top of a file. So there will still be files, the regular files, but it's just that it adds some additional logical ordering to those files. Okay?
So the heap file is not an actual file, it's more of something to store files?
There will be an actual file for a heap file, right? So you can think of it like a inheritance model, right? So a file can be a heap file as well as a file at the same time, right? Does that make sense?
I see, yeah. So like probably for Database Manager, we're going to be using primarily the heap files.
Yes, correct. Files provide just the basic necessary functionalities. They don't provide enough. So heap files come in and they help you implement things that you would need for a database, right? Cool. So as I said, heap files are real files on your file system. Now we need a way to sort of interact with them and have a class, for example, which allows you to run operations, create records, delete records, pages, so on, into this heap file. So what does the programmatic representation of a heap file look like? We have what is known as the Heapfile class. You'll see this in the heapfile.c and heapfile.h files in your code. So first, let's talk about the class itself. So as I just said, the Heapfile class builds on top of the existing file class that we have. So the very first object in this class is a file pointer, which is of type file. And then in addition to that, it has some additional details, right? So the file object itself has the same slotted page structure that we talked about. It has slots which can contain records. And this file object, it also has methods which you've already used in the previous assignment. For example, allocate page, read page, write page, right? But in addition to the file object, it also has some additional fields such as the header page, which we just talked about. So this header page contains a bunch of information about the file itself. So it contains the file name, right? So what file is this? The first page number, since the heap file can contain many pages inside it. So what is the page number of the first file? The page number of the first page. What is the page number of the last page? What is the page count? And finally, what is the record count or the row count inside this file? So, all right, so in this case, you also have the header page number. So the header page is just a regular page. It's just structured a little differently. So it'll have a page number. So that is the header page number. The header dirty flag is just to identify whether you made changes to the header page or not, so that you can flush them to disk eventually. And then the next field is the important one, which is the current page, right? So heap files have multiple pages, right? But in this structure, you can see we're only loading up one page at a time, and we're calling it the current page. Well, if heap files have multiple pages, why don't these objects have all of these pages contained in them? Shouldn't there be an object or a field in this which should be a list of pages instead? Why are we just looking at one page at a time? Any ideas? So it's the same problem that we saw in the buffer manager, right? So the heap file is basically a database, and it will have a lot of pages, which will be maybe hundreds of GBs. So if you load everything from that heap file into this thing, it'll just exceed the limits of your main memory, and you'll not be able to contain it inside RAM, right? So what you will do instead is that you'll read one page at a time into this class. And once you have to see another page, you'll just navigate to the other page, evict other pages if you have to, but at one point, you'll only be looking at one page within this heap file class. And since this page object has a next pointer and a previous pointer, you can sort of go forward and backward whenever you want. All right, so in addition to the page, right, we know that pages have what inside them? Records and slots, right? So this page itself will have a bunch of slots which will be filled with some records. So what we'll be implementing in heap files is a method called scanNext, right, which is essentially something like a select query, right? It'll take an input which will be like, oh, what condition do you want me to check for? And it'll iterate through these rows or records, and it will find the first match, return that. If you call the same method again, it'll move forwards, find the next match, return that, and keep doing that until you're done with the whole file. So we need to keep a track of what record are we currently looking at as well. So we are already keeping a track of the current page, but we'll also need to keep a track of what record are we currently at. So for that, we have the very last field in this, which is the current record. And this is of type RID, which is page number and slot number, right? So just as an example, let's say we're implementing a find method. And what this find method does is essentially just select query, right? It selects all the rows from your database which match a certain condition. So we'll load up the heap file for that database into our program, right? And to identify these pages, I'm just calling them by their colors, essentially, instead of their page numbers. In the program, it'll be numeric values. So right now, in the heap file, we have loaded up this page, which is page number blue or current page number blue. It has 4 slots, but only 2 of them are occupied by rows or records. Now, what I'll do is, to perform my find operation, I'll go through the contents of the current page. If I find what I'm looking for in the current page, I'll return that. If I don't find it, I'll just go to the next page, right? So I have a pointer to the next page. I'll just call that pointer to get the next page into this current page. So after I do that, this will look something like this, right? So the blue page goes out of the current page. The next page, which was the green page, it's loaded into the current page object. In this case, it has all slots occupied. Now I'll sort of look through these records and see if what I'm looking for is here. And then obviously the next page pointer will point to some new page. In this case, it's the orange page. All right, so for this find method, we have a page in memory. How do I look for contents within this page, or how do I find what I'm looking for in this page? I'll need to look at each record and see if it matches my condition or not, because each record is a potential row, and each of these rows can potentially match or not match my condition. So I have to iterate over all of these rows or records inside the current page and see if they match my condition. So let's assume that we're currently looking at page or record number 2 within the current page, right? So the current rec variable will have page number as green and slot number as 2, right? Now, I'm looking for some variable, some rows which satisfy a certain condition. Let's say this particular row does not, so we'll move forwards, right? We'll reach record 3. That does not satisfy my condition. I'll move to record 4. And let's say that does not satisfy my condition as well. So what do I do next? So I've exhausted all the records in the current page. I could not find what I'm looking for. Where do I go from here? What should I test next? Yeah, go ahead. Yes, I go to the next page, right? But when I do go to the next page, which of these fields in this class should I update? So this whole class has a bunch of fields. If I bring the next page into the current page, I have to make changes to some other fields in this. I have to make change to obviously the current page variable, right? I'll load that current page in. I'll also need to change the current page variable, the current page number variable, I'm sorry. And the current page number will change from green to orange. Also, I'll update the current record field to change the page number to orange. And I'll start from the very first record in that new page, right? Because I have to scan this new page from like the very beginning. So I'll set the slot number as 1. And then I'll start sort of iterating over each record one at a time. All right, so now we'll just talk about the methods that you guys will be implementing in this assignment. So these are 4 methods that you'll be working on, just like you did in the buffer manager assignment. There's a create heap file method, which creates heap files in your disk. There's a heap file constructor, which basically loads a heap file from disk and builds an object from it, which contains the same sort of structure like this. There's a scan next method, which will iterate over records and pages inside your heap file until you find a match. And then there's an insert record method, which will allow you to insert a new row or record into an existing file. So starting from the first method, which is the create heap file. So this method is essentially for creating a brand new heap file on your disk, right? So you want to create a new database, a new table in your database, so you want to create a new file for that. So you'll call this method, right? So it'll just take one argument, which is the file name, whatever file name you want to create. And it will go to disk, it'll create a new file, it'll give it the same structure that we saw for a heap file, right? It'll give it a header page, a data page, and then all those other information pieces that we had. So how do you do this? First step is pretty straightforward. You take the file name and check that it does not exist already, right? Because files should be uniquely identified by their file names. So you check it does not exist. The same file does not exist. If it does exist, just throw an error. If it does not exist, create that file. How do you create it? There's a method called db.createFile in the db class. You pass it the file name. It'll create a basic file for you. It does not give it the heap file structure yet. It just creates a simple file. Once you create the file, you'll also need to open it, right? Once you do that, we saw that these files have header pages, So we need to create a header page for this. So the way that you create a header page is how you call the buffer manager's alloc page method, which you have seen previously. And this method will just give you a brand new page, right? The type of that object will be page. It will not be the same type that you need. So if you see here, the type of the header page has to be file header page, not page. It's a special type of page. So the way that you can sort of convert a page into a header page is by just doing this type of typecasting. So you take you take the object returned by the alloc page method, which is of initially page star pointer, or the type of that pointer is page, and you just assign it to a file header page pointer using this typecasting mechanism. So this might seem a little weird. It might seem like we're taking an object of one class and casting it directly into another class, even though there's no inheritance or anything like that. But that's not exactly what we're doing. We're not casting objects directly. We're casting their pointers. So in this case, what is happening is that the alloc page just allocated a bunch of memory for me. It does not know what structure it has. It just gave me that block of memory, and I'm just replacing the expected structure of that memory from page to file header page, right? So I can just use that memory however I want. I can typecast it to any other variable if I want to. But in this case, I want to use it as a header page, so I'll just typecast it to a header page pointer. So now we have a header page, which is great. Next, what we will do is we'll create a blank data page, right, in which we'll actually place the records. Remember, this header page does not contain any rows or records. It's just metadata. So we'll create a new page, which will be a blank page without any records yet, again using the alloc page method from the buffer manager. And we'll initialize it using this new page init method. So whatever page you get, you'll call the init method on it, and that'll sort of set up the page structure for you. For the file header page, we have not yet set up its variables as of now, right? It has certain fields like the page number, starting page, ending page, so we have not assigned that yet. So after you create the new page, you'll assign those fields. So these are the fields that you'll have to assign. So the file name will just be whatever file name the user wants you to create. The first page number will be what? Where do you get the first page number from? Any ideas? So you created a brand new file. It has a single header page. It has a single empty data page for now. And when you created that empty data page using the alloc page method, it gives you the page number of that new page, right? So that's what you'll use in the first page variable. Since there's just one page, you'll just use the same variable as the last page number as well. Page count will be 1, obviously, because there's just one data page, right? We don't count the header page in this. And the REC count, or the record count, is 0 because there is no records inside this file yet. And once all of this is done, you will just unpin the pages like you have done in the previous assignment. So right now we have some current page loaded into memory, or like these header pages loaded into memory. Before we close the file, we want to unpin them so other people can start using the buffer manager instead of your pages taking up space forever. You unpin these pages and flush and close the file. So after you implement this method, what you can do is you can just call it like this: create Heapfile, give it some file name, famous chemists. It'll go to disk, it'll create a new file, it'll give it a new header page, which will have all the file name, page count, and first, last page number variables. It'll also have an empty data page, which does not have any records in it yet, but you can start inserting them afterwards. So this is the initial structure that is set up after you call the create Heapfile method. All right, so now we have the file on disk. Now what we want to do is we want to load this into our program and sort of start interacting with it, start running some methods on it. So the way we do that is by loading this Heapfile object from disk into a class into a class called the Heapfile class. They're named the same. It's a little confusing, but this is basically the programmatic representation of the Heapfile. And the way that you sort of instantiate this class is using the Heapfile constructor, right? It takes in one argument, which is the file name. This is the file it will read from disk and sort of build the Heapfile object around. And return status is one of those return variables that you will assign. So depending on whether you were successfully able to create open that file or not, you'll return a status of OK or not OK. And just to remind you what we're sort of trying to construct, it is this structure over here. It's the same field that we saw previously, right? The variables of the Heapfile class. So this constructor should basically be able to populate all the fields inside this. So the first thing you'll do, you'll take the file name that the user gave you, you'll go to disk, you'll see, is there a file that exists with that name or not? In this case, you would expect that it should be there, right? Because you're not creating a heap file on disk, you're just loading it from the disk into a heap file object. So this file should exist, and if it does exist, you will assign it to this first variable or first member in this class, which is the file pointer. Next, what you will do is you will load in the header page. How do you do that? So since you have the file already, you can call this method called the getFirstPage, and this will just return the overall first page of that file. And since we have created the heap file in such a way that the very first page is a file header page, so this getFirstPage method will return the header page, and you can assign that to the header page variable. How do you figure out the header page number? Well, once you read the header file page into your memory, right? Oh, sorry. My bad. So just a small correction here. So when you call the getFirstPage method, it does not return the actual page itself. It just returns the page number of that page, all right? And how do you read that page then? How do you actually get the object corresponding to that page? You have to call the buffer manager read page method, right? So the getFirstPage method gives you the page number of the first page. The read page method actually reads that page number into your memory. And once again, it will read an object of type page, not type file header page. So you'll have to do the typecasting again here. And then once you do that, you can set these three variables highlighted in green: the file header page, the header page number, and the header dirty flag. By the way, what would the header dirty flag be once you sort of create this heap file object? What would you assign its value as? Excuse me. Well, this flag just indicates that you make any changes to the header page or not. Since you just loaded this file from disk, you have not made any changes to it, so this will just be false, right? Right, so moving on, now we want to instantiate or assign the current page object. How do we do that? Well, since you just read the header file page or the header page object, the header page contains the page number of the very first data page. So again, you call the read page method, and you read that page into the current page. You assign the current page number. Current dirty flag again will be false since you haven't made any changes. So all of that is loaded into the object, and the last field that we have to assign is RID. Since we are not scanning anything yet, we'll just assign an RID value of null RID initially, which means there is nothing that we're pointing to right now. Once we start scanning things, we'll update the RID accordingly. Moving on to the next method, which is getting a record by its RID. It's a pretty straightforward method. It takes an input argument, which is what RID do you want from the current file, right? From the current files pages, you have to go to a certain page, pick a certain slot number. That information you'll get from the RID input. And once you find that object, you will return that in the REC in the REC argument passed in the function itself. So if you think about how you can scan and find a particular page and a record inside a heap file, the algorithm is just sequential, right? You look at the current page. If it's not the page you're looking for, you go to the next page, keep going to the next page until you find the page you're looking for. And once you reach the desired page, inside that you find the particular slot number that you're interested in. So the basic case is that the very current page that you're on, it matches the page number that you want to go to, right? So current page number is equal to RID.pageNumber. If that is the case, then you can just call the getRecord method on the current page and get the record corresponding to whatever RID you have provided, right? And once you do this, there are some fields in the heap file object that will change. For example, the current record pointer, we had this field. Let me see if I can find it. So the very last field in this, since we have moved to a different record now, we're looking at a different record now, you'll have to update the current record, right? And you'll have to see if there's any other fields in this heap file object that you need to update. Once you, if you found the correct page, right, you will unpin the current page. 1 second. Okay. Oh, so if the page that you're currently on, it's not the desired page, then you want to move to a different page. So before you move to a different page, you will have to unpin the current page, right? Because you don't want to keep the page pinned in memory so that no one can take its space in the buffer manager. So if you want to move to a different page at any point, make sure to unpin the current page. Once you do that, you just go to the page number that they want you to go to, and then go to the record number that they are interested in. You can find that from the RID field. And once you do all of that, make sure you're updating the current page number, the current dirty flag, and the current record pointer inside your Heapfile object. All right, so the next method we have is scan next, and we just briefly discussed this earlier. So scan next just basically scans through all the records in your database, and it matches a certain filter condition with these records. If they satisfy the condition, it'll return them. If it does not, it'll just keep scanning forwards. So this method just takes a single argument, and that is actually the output argument. So this is the RID of the matching record inside your file. So it seems like this method is incomplete, right? Where does it take the filter condition? Like, how do I specify what condition I want this thing to check, right? So that might seem a little confusing, but the thing is that the responsibility of setting that filter is not the responsibility of this method. It's a different method inside the Heapfile class. It's called the scan next method. Sorry, not the scan next method. It's called the start scan method, I think. And that basically sets the filter value for which you want to check. And then this method just sort of iterates over records and scans them and compares the values and returns them. So once you implement this method, later on you'll be able to build a system which can run a query like this, right? So some select query where you're selecting from a file or from a database or from a table where some column satisfies a certain condition or satisfies a certain value. So what is missing in our Heapfile, this scan next method, we already talked about that. The filter is not present here. It's set up in a start scan method, which is separate from this. Now, if you think about how this query would be executed or how this would be evaluated in a database, you have a bunch of pages. You start from the first page, go to the first record in that page. You want to check if the alias column inside that row is equal to some value, in this case, Heisenberg, right? So for each record, you know that the alias column is the second column in that row, which means it starts at a certain offset. So let's say the offset is 20 bytes or something. So you'll start looking from 20 bytes and see, oh, starting from 20 bytes till 25 bytes, is the value equal to Heisenberg or not? And if it does equal Heisenberg, then you'll return that record because it matches your condition. If it does not return that record, if it does not match your condition, you'll just move on to the next record, right? This part you'll not have to implement yourself. I think there's already a function called matchRec which does this, but you just have to call that function in your code. So how do you actually implement this? So first of all, you'll check, is the current page that I'm looking at a valid page or not, right? So there are cases where this current page might be null. In that case, there's nothing for you to sort of iterate over, right? So in that case, you'll have to do something else. We'll see that in a second. But if the current page is a valid page, that page will have records, right? What you'll do is iterate over the records of that page, and you'll try to match if the condition, the filter condition matches your current row or not. And the way you do that is by calling this matchRec method. So whatever record you're currently looking at, you pass that into this matchRec function. If it gives you a return value of true, that means this current record matches the filter condition. Therefore, it is a valid response, so you return that. If it does not match, you move to the next record. And if you exhaust all the records within a page, then you will, as we discussed previously, move on to the next page. And the way that you do these things is by using the next page and the next record functions within this Heapfile class. Also, in case you reach the very end of a file, right, you exhausted all the rows or all the records within all pages, there's no page for you to move to next. So what do you do in that case? So in that case, you'll just return a status of EOF, which indicates the file has ended. I still haven't found what I was looking for. So if that happens, the user can call scan next again, and then it'll sort of loop back and start looking from the very beginning again. So again, in this case, you'll be iterating over records and moving between pages. Every time you move between pages, you move to a next page, you should remember to do cleanup, which means you unpin the previous page, you update all the relevant fields in the Heapfile object, and once you load in a new page into your current page and you want to scan it, start from the very first record, right? Don't skip any records. Now, if your current page was invalid while you were scanning, well, in that case, just go to the very first page. The way you can do that is just call header page, first page to know the page number of the first page. Go to the first page, start from the first record of the first page, and do the same exact steps from the previous slide. That is sort of iterate over each record and each page, and then keep doing that till you find it or not. All right, I think this is the last function that we're talking about here, inserting a record. So this insert record method will take a record object that you want to insert into your heap file. This is the same as sort of inserting a new row into your database. And once this record is inserted into the database, it will be placed in some page, in some slot, right? So what page and what slot, that will be returned in the RID output. So if you insert this new record into, let's say, page number 10 and record or slot number 11, then this RID will have page number 10 and record number slot number 11. Now, we saw pages have a fixed size. They have a fixed number of slots available. So when I'm trying to insert a new page, or not insert a new page, insert a new record, which is inserting a new row, the sequence I should follow is something like this, right? So first I'll check, does my current page have space to accommodate a new record, right? If it does, fair enough, just insert it right there. Remember, we're not ordering any of these records, so they can be in any random order. So if the current page has space, just put the record there. If it does not have space, go to the very end, create a new page, a brand new page, insert that record there, right? So that is what we're doing here. So if the current page is valid, I'll try to call insert record on this current page. If it returns a status of OK, that basically means there was space inside the current page, and I inserted the record there. It'll give you the RID in return. If the status is not OK, well, there was no space in the current page, so I couldn't insert it here, so you have to find a new home for this. And how do I find a new home for this? I'll just create a blank and a brand new page, put it at the very end of my page list, right? Remember, pages are ordered in sort of a doubly linked list fashion. So I'll create a new node at the very end of my doubly linked list, insert this record that I'm trying to insert into this brand new page, since it has no records in it, so it should be able to accommodate this new page. Also, since I'm sort of moving to a new page now, I will update my current page variable and update it to the new page I'm creating. I will call insert record on this newly created page to insert this record that is being passed in the input. And I'll also update the header page fields. The header page fields need to be updated because my page count has changed, my last page number has changed, so I need to update that as well. And also one thing that you might guess we need to do is, since we're inserting something at the very end of a doubly linked list, the last or the previously the last variable or the previously the last node, it has to be updated so that it points to the updated last node, right? So there was a last page previously, now there's a new last page, so you need to make sure that the previous last page points to this new last page. What happens if the current page is invalid? Well, obviously you cannot insert anything into an invalid current page, so what you'll do is just go directly to the last page in your file, try to insert the page there, try to insert the record there, and if there is no space there, just do the same process as we did in the previous slide. Just try to create a new page and then add it at the end of the doubly linked list. So that's basically all the methods you'll be implementing. This basically covers all of the sort of expectations that are there for this assignment. There might be some details which might not be covered in the presentation itself, so you'll have to figure out what fields exactly you need to update, but this covers most of the basic flows that you need to set up for this assignment. So do people have any questions about anything so far? Waiting for 5, 4, 3, 2, 1. All right, no questions. So I'll be here for a little while longer. If you want to discuss anything separately, you can come up and discuss with me. If you don't have any questions, thank you for coming, and I hope you have a great day.